Hello, so here the problem number 7, and in this problem we have to uh, create a new linked list according to the given linked list and the input number. The input number is the partition number, which according to which we have to filter numbers from our input linked list. We need to put smaller numbers to the left of the input number and the greater numbers to the right. And also, if there is equal numbers to that partition number, we must put all those numbers to the middle of the linked list. So, for example, we have this linked list and we have this partition number like a tree. So the output for this given linked list should be as following. So 2, then 3, and then 10 or 4. So actually the order is not important. The most important thing that the 3, which is equal to the partition input number, should be at the middle of the our output linked list, and the 2, since it's smaller than the 3, it should be on the left side, and the 10 and 4 should be on the right side, and the order between 10 and 4 is not important, so it could be 10 and 4 or it could be 4 and 10. So either versions are correct. So how are we gonna do this? So in order to solve this problem, we will create 6 different variables. One is small head and small last. So these 2 nodes will be used to collect and keep the nodes that are smaller than the partition number value. So we'll just, to do this small head, we'll just put numbers that are smaller, like for example 2 and 1 and etc. So also we'll have another 2 nodes for the numbers that are equal to the input partition value. So we'll keep all those numbers in these nodes. So we will create a new linked list according using these 2 nodes. And another 2 variables will be grade head and grade last. So these 2 nodes will be used to save the the elements from the linked list that are greater than the partition value. So using these 2 nodes, we will create another linked list. So how it's gonna work, so let me show you. So I will define a current node just to go through all nodes in the linked list, and first value will be 10. I will take this current value, which 10 will compare with the 3, so like 10, 3, and we see if it's equal or not. If it's when I see the 10 is greater, so I will take this 10 and we'll make it equal to grade head. So grade, so 10 will go here, so it will our grade head, and at the same time it will be grade last because it's just one single element right now. Then I will go to the next node in my linked list, so it's 4. 4 is also greater than 3, so this time I will move I will also put my 4 to the grade linked list, but it will be next. So I will move my grade last, and my grade last will be like grade head next, will be my grade last, so it will be grade head, it will be 10, it will be stay as it is, but my grade last will move to the next element, and there we will put 4. Yeah, so then we go to the next element in the given linked list. We see that it's 2 and 2 is smaller than the 3, and this time this element goes to small head, and my small head will be 2. At the same time it will be the tail of my small linked list, so small last also will be pointing to 2. Then it goes to the next last element, which is 3, and since 3 is equal to partition value, it will go to equal head and equal last, since it's just a single element right now. So at the end we will just connect all those nodes, like we will make small next equal to equal head, and equal last next will be equal to grade header. So at the end we will have such a linked list. So how are we gonna do this? So I already wrote some code just in advance, just to like save the time. So here sorry, so we're returning node and the input values in the header of the linked list, and the partition value with the x. So here I'm declaring 6 nodes, like grade head, grade less, so it's just for header and tail. The same thing for the nodes that will be equal to the partition value, like equal head and equal tail. Then the number, the small head and small tail is just for the numbers that will be smaller than the partition value, and the current node is just to go through all elements in the given linked list. So we're just starting our while loop, and we will run it until it will reach the end of the linked list, and we check if the data from the current node is equal to the partition value. If it is equal, we're just putting it to the equal head. Also we check if equal head is null or not. If it is, so we're just putting the new value to our equal head, and our equal head and equal last always will be equal to the current node. If not, if we already put some value to our equal head, so we're just moving our equal tail pointing to the current, and also we're like resetting our equal tail to current. The same thing it goes if the element from our node is greater, so then it goes to the greater head, grade head. Of course, if it's null. If it's not, like here, we're just moving our equal last next to current, and we're just redefining our equal last to current. And the last thing else, meaning that our current data is smaller than the partition element, then we're checking if we have something in small head. If we don't, we're just setting all currents to small head and small last, if we have something on our current small head, we're just moving our small tail, and current equal to current next, we're just moving to the next node in the given linked list. So this code is just for creating all these 3 separate linked lists according to the comparison with the input value. Now we need to connect all these linked lists, and so here we start to connect all these linked lists. So first of all, we'll just, since we already built all these 3 separate linked lists, at the end we'll just need to change the pointer of our last third, this one, gray tails pointer to null. So because, for example, right now it's just pointing to 4, but since it's the last element, we need to pointing it to null. Like, for example, if it's not null, we'll just say it to point to null. So after that, we'll just start connecting 3 separate lists. So first of all, we check if we have anything in our small head, checking if it's equal to null or not, meaning if we don't have anything here in small head, like if we don't have these 2, so we go directly to equal head, check if it is has anything. If it doesn't, like there is no 3, so we're just returning the value of great head. So meaning that all the numbers in the given linked list were greater than the partition value. So, but in our case, we have values on all those 3 linked lists. So, but still, okay, we check if our small half is equal to null. If it is, we make another check if our equal header is null. If it is, as I told you before, we are just returning great head. So just let me continue this in the next paper. So we're returning that great head, but if we have something on our equal head, so we're just connecting our equal last tail next, connecting it with a great head. So, and we will return equal head. So meaning like we don't have small head, but we have equal head. In that case, we'll just connecting the tail of our equal with the greater and returning the 3. So it was if we don't have anything in our small head. But if we have, for example, in our small head, but we don't have anything in our equal head, like the middle, like we will need to connect just small head and greater head. So we'll just connect our small tail next to great head, and we will just return small head. Otherwise, if we have in our equal head, we'll just connect our small with our equal, and we also will connect our equal with the great, so great, the linked list where we keep all elements that are greater than the partition value. And after that we'll just return small head. So time complexity for this, so we're just going through all elements in the linked list. So after that we're just connecting them, so it will be like, in worst case it will be n plus 2. I mean 2 is just for connecting 3 separate linked lists. So then the time complexity will be order of n, and space will be order of constant, because we're declaring 7 not variables, but they are not additional data structures, and it doesn't depend on the number of operations or number of elements in the node. It will be keep constant, so it will be order of n. So